So then we come up to the permutation symbols. In this case, here we have a number of permutations of 5 objects taken 2 at a time. And the way it's set up is the 5 factorial over the 5 minus 2 factorial. And you'd say, what's a factorial? Well, factorial comes up when we're studying about the number sequences. And the factorial, the way it works is a product of all integers from 1 all the way to whatever the number indicates. In this case, 1 all the way to 5. So in this setup, we write this 5 factorial as 5 times 4 times 3 times 2 times 1. So if you multiply all those integers, you'll get some amount. Divided by the 5 minus 2 is 3 factorial. So that becomes 3 times 2 times 1. And the neat trick about this is once we spread out, once we write out, expand out the factorial, the products, whatever is the same from top and bottom, we could cancel them out. So 3, 2, 1 cancels out the 3, 2, 1 on the bottom. So all that's remaining is 5 times 4. So in this case, it's 20. That's the number of permutations when you have 5 total objects taken 2 at a time. So how do you set this one up? This basically becomes 9 factorial divided by 9 minus 4 quantity factorial. So that becomes 9, 8, 7, 6, 5, 4, 3, 2, 1. You can see how tedious this can be. Divided by 5 minus 4 is 5. 9 minus 4 is 5. So 5, 4, 3, 2, 1. And just like before, we could cross out the 5, 4, 3, 2, 1 from top and bottom. That leaves us with the product of these integers. And still, it gets kind of hectic. So enter the calculator. And I have it set up so we have the probability mode. Just to see how it works, let me show you. Okay, the permutation of 5 objects taken 2 at a time, or permutation of 5 choose 2, in my calculator, you could punch it in as 5 permutation choose 2. And that says 20. Isn't technology awesome? And now, let's do this product of these integers first to verify. So we got 9 times 8 times 7 times 6. And that gives me 30, 24. Will that be true if I go ahead and use the keystrokes for 9 choose 4 permutation? So 9 permutation choose 4. There it is, 30, 24. So it works. Now this one I do have to show you. It's a lot easier than you think. So we have 16 factorial over 16 minus 0 factorial. Well, isn't that like saying 16 factorial divided by 16 factorial? And should I go through the trouble of listing out all the integer, its product, just to cross it out? Or can I just simply say this is 1? And maybe we could check it on the calculator just to be sure. So we say 16 choose 0, 1. We could even say, check this out, I have a factorial key. So, in parentheses, 16 factorial, close parentheses, divide that by 16 factorial. Would that give me 1, hopefully? Ta-da! So either way works. So there's that. And finally, for this segment of permutations and counting principles, we come to a section where we talk about the number of possible ways of arranging a letter when you're given a set of words. For example, if we said Tom. I have a neighbor named Tom. He's cool. Well, how many ways can we rearrange this? Well, we have 3 different letters. So we could say, that's one way. We could say OTM. Or we could say MTO, or we could say MOT, or we could say OMT, or we could say TMO. Did we do TMO yet? No, not yet. So there's 1, 2, 3, 4, 5, 6 different ways of doing it. Or since there's 3 letters, it'll be 3 factorial, or simply 3 times 2 times 1, which is 6. So that's another way to find many ways of arranging 3-letter words that are different. But what do you do if some letters they give you, there's a repeating letters? So that's what this is about now. Okay? So, and there is sort of a general form to deal with that. And it's given as the nth factorial, or n factorial, the total number of letters, divided by a repeating number of letters. And if there's more than one of them, we say q of 1 factorial times another number until we get a total of whatever the total repeating letters we have. That's the general setup. So in this case, we have 3 total letters divided by 2 letters that repeat. So isn't that like saying then 3, 2, 1 divided by 2 times 1? So 2 and 1 can cancel out. The total possible ways of arranging Bob is basically 3 ways. Yeah. It's B-O-B, O-B-B, B-B-O. That's about it. That's kind of boring. Now, you tried to figure that out with Alabama, and I couldn't spell this very correctly. I hope it's right, but Connecticut. You try that one. So you said for Alabama, there are 1, 2, 3, 4, 5, 6, 7 letters. So that's going to be 7 factorial on the top of this general form. And what is one of the repeating letters? So I have here A, 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 A. So I have 4 letters that repeat. So that's 4 factorial times, is there anything else that repeat? That is about it. And so 7 factorial divided by 4 factorial. So that's like saying 7, 6, 5, 4, 3, 2, 1 divided by 4, 3, 2, 1. If you said next time, if I knew that 4 factorial gets cut off, can I just not write that? Yeah, that would be the smart thing to do. So in this case, 6 times 5 is 30. 30 times 7 is 3 times 7 was 21 with a 0. So there's 210 ways of arranging this letter if we have repeating letters of A. And finally, the Connecticut. How many letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Holy moly, 11 letters. 11 factorial divided by any letters that repeat. Let's see. I see a C and a C and a C. So I have 3 C's. So that's going to be 3 factorial times. I see a T and a T. So that's another 2 factorial times N, N. So that's another 2 factorial. Anything, any other letters that repeat? No? No other vowels? No? No consonants? No? Okay. So here we go. 11 factorial. 3. You know what? Let's just use a calculator for this, shall we? It's getting a little too big. So I go. This is how I do it. 11 factorial. Divide that by, I'm going to need a parentheses, and another parentheses for this 3 factorial. Close that parentheses, open up another parentheses for 2 factorial. Close that parentheses as well, and open the third parentheses for the denominator, and then 2 factorial. Close that, and the final denominator parentheses, let it execute. I get 1663200. There are 1,663,200 ways of arranging this letter, Connecticut. There you have it.